Hi, welcome to Mrs. Park's Algebra 1 class. We are starting Chapter 4, Section 1, Graphing Equations in Slope-Intercept Form. So in Chapter 3, we've explored standard form, which is ax plus by equals c. So we've learned how to do that in Chapter 3. But in Chapter 4 now, we're going to learn on how to do slope-intercept form. Okay. Because this is the very first time using this format of lesson, I'm going to be having a lot of trial and errors. I'm not quite comfortable with using this video format, so just feel free to give me any comments or suggestions, if you will. Alright, so slope-intercept form. Slope-intercept form, oops, I didn't want to do that, is exactly what it says, a slope and an intercept. So you have a slope-intercept form, you will write as y equals mx plus b, where this m will always stand for your slope, and this b, which will always be a number, will stand for your y-intercept. Okay, and here you go again in the textbook. If you have y equals 2x plus 6, the 2 will represent the slope, and the 6 will represent the y-intercept. Okay. Let's try to make that a little bit larger. Here we go. Alright, so if they ask you to write and graph an equation, and they're telling you, write an equation in slope-intercept form for the line with a slope of 3/4 and a y-intercept of -2. So again, your m is your slope, your b is your y-intercept. So we're going to rewrite this, y equals mx plus b, and you need to get used to that by now because you will hear this over and over. So your m here they're telling you is 3/4 x, don't forget to write the x, and your b, your y-intercept here is -2. So instead of writing +2, I'm going to write -2. When they want you to graph this equation, you're always going to start with the y-intercept. This is your starting point. In chapter 3, when we did direct variation, we always start with 0, 0. Now the difference is we have actually a y-intercept. So we're going to start -2 on the y. Here's -1, -2. So we're going to put a point there. And from that point, you're going to rise 3 and run 4. Remember, slope is always rise over run. So you're going to rise 3, you put 1, 2, 3, run 4, 1, 2, 3, 4, and there's your other point, and you're just going to connect the 2 points and make it into a nice line. Remember, linear equation has the word line in it, so it means a straight line. Okay. Moving on to the next page. Now, when you are given a graph linear equation, when you are given a form in a standard form, remember ax plus by equals c is a standard form, you are to rewrite the equation in slope-intercept form. So how do we do that? In the textbook, they like to write horizontally, but in our classroom, we are used to doing it vertically. So let's do that. Plus 2y equals 6. All right. So my goal is to have everything, bottom line, I want y equals everything else on the right side. In order to do that, I'm going to take away this 3x on each side by subtracting, and that will eliminate 3x minus 3x is canceled out. What comes down here is the 2y. You can't take away 3x from 6, so I'm going to just rewrite it, minus 3x plus 6. Now we're going to divide each side by 2 to eliminate that, because 2 over 2 equals 1. Now I have what I wanted, y equals negative 3 over 2x plus 6 divided by 2 is 3, so I'm going to put positive 3. So now we've rewritten the equation, which was given in standard form, into my slope-intercept form. It's a lot easier when you're trying to graph an equation that's already in slope-intercept form. Again, our starting point is always going to be our y-intercept. It's a positive 3. So I'm going to start with positive 3 here and make that nice dot. From there, I'm going to rise 3, run 2 to the left. Remember, when it's a negative, it's going to run to the left. You can either do that, or you can go run down 3 and run to left. To your right, whichever you prefer. So let's do what we're used to doing. Rise 3, 1, 2, 3, and run 2 to the left, 1, 2, and there's our other point, and connect the dot, and you'll have an equation, your line graph. In the textbook, they decided to run down 3 and rise. Well, it's not really rise because you're actually going down. So you go down 3 and run to the right, and you'll still have that same point there. Okay, and there we go. There's your graph. Okay, let's try a standardized test example 4. Which of the following is an equation in slope-intercept form for the lines shown below? So this time they gave you the graph and they want you to write the equation. So again, this point right here where it meets the y is called the y-intercept. So we have y equals, again, mx plus b. And they're telling you that this b, the y-intercept, is at positive 1. So I'm going to just go ahead and write positive, plus 1. Now, I see there is another point here that they're passing. So I'm going to count how many rows. That's 1 over. How many did I run? 1, 2, 3. Again, if I'm going to the left, it's going to be a negative. So negative 3. Don't forget to put down the x. So that's my equation. Y equals negative 1/3 x plus 1. Let's see if that's here. And there it is. Oops. And my answer is C. Y equals negative 1/3 x plus 1. Alright, here is a real world example. Okay. Oops. We actually want the question fully visible. Let's try to zoom out a little bit. One more time so we can see the entire problem. And there we go. Okay, real world link. In 1997, about 2.6 million girls competed in high school sports. The number of girls competing in high school sports has increased by an average of 0.06 million per year since 1997. So again, in a lot of these word problems, they're going to throw some numbers at you, like this 1997. We don't really need that information for now, because a lot of times when you read word problems, you want to just highlight all the numbers, and you automatically think you'll be using all of them. But in this case, we probably won't be using that information for the first problem. Okay, so write an equation, linear equation, to find the number of girls in high school sports after 1997. All right. If you allow the number of girls competing to be, let's G stand for that, equals rate of change, number of girls competing, times number of years plus amount at start. So G equals Rate of change, they told us right here, the average of 0.06 million per year. So that's the rate of change, times years, we don't know what that is, we'll just stand for number of years, plus we started with 26, or 2.6. So here's our equation, g equals 0.06n plus 2.6. Now let's graph this equation. So we start at 2.6, again, our y-intercept is where we always start, okay? And then 0.06 is our slope, so that means 0.06 over 1. So if we rose 0.06 slightly and then run 1 and connect the dot, that's where our graph will look like. And there's your graph. So part C of the equation, the problem says estimate the number of girls competing in 2017. So here, instead of n, we're going to substitute it with the number 20 because from 1997 to 2017, that's 20 years. So instead of n, we put 20 in calculator, and that gave us 3.8. That means in 2017, there's probably going to be 3.8 million girls competing. Okay, so there's our quick lesson